Hi there, I'm Blair Johnson, and in this talk I'm going to describe how you'd use the software DSTAT, which I wrote, for calculating effect sizes for use in meta-analysis and other purposes, I suppose, but the primary purpose is meta-analysis. So to begin, we have an outline for you, so I'll give you a brief history why it's important to have effect size software, a good rationale. I'll describe how you install DSTAT. I'll tell you how you configure DSTAT. I'll preview some of its important features, but I won't go in detail because that's better for a separate talk. And I'll end with a call for collaboration to replace DSTAT because it is old and clunky. Okay, so brief history. Obviously, maybe, it seems like it's obvious anyway. In practice, we have in practice, there are lots of ways that studies report statistics. I mean, Mann-Whitney used chi-squares, f-test, t-test, means of standard deviations, all kinds of variations. And there are also numerous studies that are out there. So a question is really, how much do results differ? And can we make sense of them? So effect size is really a key for meta-analysis because now you've got a standardized metric for study outcomes and you can model these effects. Now, the statistical operations that are needed to convert many source statistics into effect size are complex, and you need to have two coders to calculate them independently. Here I am with the one who taught me about calculating effect sizes. That's Alice Egley. And we used to spend hours recalculating things using our calculators in the days before modern software. When we had a discrepancy, we'd often have to rebuild something very complex, and our time is valuable, so it dawned on me we could use software to do this. So by virtue of having the software, using the standard ways of calculating effect sizes and saving the work, you can just compare your results, and maybe you can tell right then that someone has the correct solution, and that's why you diverged. So it went back to my graduate school days, and then starting in the late 1980s and beginning into the 90s, I released software called DSTAT, Statistics for D. And it was broad software. It was not just calculating effect sizes. It also was to do model testing of effect sizes. And so it was originally commercial software. I've since regained the copyright to the software. I can distribute it for free. Just drop me an email. Okay, here's how you'd install DSTAT. The problem is DSTAT was created in the MS-DOS environment. Very quaint, but actually there are a lot of programs that are still in use in that environment, especially game programs. So if you want to run it, you need to use a DOS emulator for any kind of contemporary computer. So you can just search on the internet and download one that matches your operating system. DOSBox, which I've got highlighted on the right, seems to be a recent favorite for people who do this stuff. You would download DSTAT.exe into a directory or folder. And there's an example of where I might put it on my computer, and that's how I've done it on all mine, just for it by default. And then you run the emulator, and you get a picture that looks something like this. And after that, you type in these commands to mount the directory that you just put in. And then you tab over to that C directory, and then you launch the command DSTAT, and up should pop DSTAT. It'll have a little bit of a, it'll detect whether it's got an ini file. Don't worry about that stuff. And then once you get in, you should see a directory that looks a lot like this. And I'll switch back to my software if my computer lets me, so I can actually interact with it while we record this session. So here we are on the opening screen of DSTAT. And you can see at the top it says not customized yet. If you happen to open a copy of DSTAT and it's already got some other definition, then it's already been predefined by someone. But you can go to the installation menu, so just type the letter that's highlighted. Installation menu is I. And now you can change all kinds of different things. So see the alt labels box at the bottom. So right down there. If we go in there, we can change it to be we can tell it the type of research name. Maybe it's intention behavior. And you don't want this to be too long because it's old-fashioned and it's just not going to, it's going to truncate if it's too big. First group might be something like treatment, and the second group might be control, like it was by default. We don't really care about the label output. We can permanently save these so the next time I launch it, I don't have to redo it. So I press the P option to do that. And then nothing else here really needs to be changed. But now I should give you an idea. If you define which group is which in this menu, it's going to be a lot easier for you to enter information you need to calculate effect sizes. So that's the reason we're doing this. Now if we go back to the opening menu, there are all kinds of things we can do in here, and I'll just go into the means menu to give you a little sense of it. Like one that's very useful is you've got means and standard deviations, say for, well, even just one group, one subgroup for each of the two. You could have multiple subgroups and it will do it. Let's make it easy for ourselves and make it equal n. Let's imagine maybe 20 people in a cell. And let's say no, in this case, they don't have the same standard deviation. So in the treatment group, you'd enter whatever your mean values are that you're comparing, and I'm just going to invent some numbers here to give you some, let's see, standard deviation of 1 and just see how this works out. We'll do that for both groups, well, maybe just slightly different for the sake of argument. And boom, it calculates your effect size for you. So what it's done is to pool the standard deviation from those two estimates that come out of your entries. And then it uses that as a denominator for the difference between the two means, which is the numerator in the equation. And there's all this information about it. It's got a raw effect size, which is uncorrected for sample size. And there you can see the corrected sample size, the corrected effect size, which is the Hedges bias corrected effect size. And confidence intervals for both if you want them. And even an equivalent R value, which is handy for people who've never been fooling around with these kinds of statistics before, and a p-value for that R value, so for what it's worth. There are lots of others. I mean, if you had multiple subgroups in here, here's a really handy way to pool multiple groups from the same study. And you could do lots of other things in DSTAT. I mean, you can just look at the menu here and get a sense of it. In another talk, I'll talk you through these options at the bottom, D and U, which basically are about factorial designs or one-way F values. But like I said, that's another talk. Anyway, there's a brief introduction to DSTAT. Okay. So obviously DSTAT has an array of equations for calculating effect sizes, and a lot of those are still very useful. And some of those features don't appear in any contemporary software, as far as I know. That's the caveat. I mean, there might be something out there. Obviously, if you find it and you know about this, please let me know what it is, because I'd like to, if we could stop using DSTAT forever, that'd be great. The problem is there just still are some useful things that come in handy in the software. So especially the problem of divining, estimating what the pool standard deviation is when it's not reported. So in studies that have one-way ANOVAs or factorial designs, like 2x2x2s and 3x2 designs, if they don't report the pooled standard deviation or the mean square error, but they do report the means and the F value for at least one of the factors, you can in fact get back to a pooled standard deviation. Because as we know, the pooled standard deviation is equal to the square root of the MSE. So if we can divine that, now we know what the pooled standard deviation is. Okay? And you know, I have a manual for DSTAT, and it walks you through all this stuff if you're interested in those things. Two effect size calculations that are in the software should not be trusted to be accurate. I'd say they're rough. So there's known to be better options for estimating effect sizes from proportions and frequencies. And there's known to be better options for using significance levels to convert. And that's, again, something else I'll show you separately. Now, DSTAT will estimate fixed effects models of effect sizes. In fact, it'll do it really quick. But there are many, much more sophisticated options available that I would advocate instead of DSTAT at this point. So don't use those models either. Now, I would like to issue a call for collaboration to replace DSTAT. And the Campbell Collaboration's effect size calculator is a good start, in fact a great start in many ways. And it even has, I've shown on the screen, a one-way F value recovery function. This ought to triangulate with DSTAT's estimate. So I'll challenge you, check it out, see if it does. That was authored by David Wilson, by the way, and I think that it's continuing to develop over time. So I think he's already collaborating, and so maybe join the team and try to get more of these estimates to get standard deviations when are not there. And, one option might be a Shiny app. You could put this ANOVA rebuilding routine on the web for everyone to use forever. And the result would be more comprehensive meta-analyses. You got to wonder how much of what we call publication bias is actually due to just not estimating effect sizes from studies where they could be estimated if you had this full standard deviation. So then past studies would be more likely to be used in meta-analyses, and that would be a better world. Anyway, thanks for taking in this little talk. And if you need my contact information, it's there. Have a great day.